Good day, ladies and gentlemen. Today we are going to work on Chapter 5, Lesson 3, the Distributive Property. Our I can statement is I can use the distributive property to simplify expressions. As with the other two lessons in Chapter 5, you are taking notes as you go through this video. You should stop me when I'm going too fast and stay caught up with your notes. Your responsibility, in addition to writing the main idea and the notes that I give you, is to add to your notes by including a cheat sheet for each of your main ideas. I will give you a little pause between each of our main ideas so that you can add the cheat sheet. 3 vocab words for today. The first one is distribute. The title of our lesson is the distributive property, so we need to know what distribute means. It means to spread evenly throughout. For example, think of yourself playing cards with a group of friends. The dealer usually gives cards out to everybody sitting at the table by dealing them or giving each person the same amount of cards. So they're distributing the cards evenly to their friends while playing cards. Like terms would be terms that have the same variable raised to the same amount. So for example, a like term would be 2x plus x. Okay, 2x plus x, this is really a 1x, so we are talking about 3 x's here. We also could call constants like terms, and constants are simply numbers. For example, if you have 7 plus 2, you can combine them to make 9. I know that you've done that many times in your life. Think about them not as just adding 7 and 2, but combining a positive 7 and a positive 2 to make 9. So like terms that have the same variable raised to the same amount, also like terms could be considered constants. We're going to move to number 2. Before we move to number 2, you should take a moment to write your cheat sheet and then move on to number 2. Distributing to mental math. So here we have number 4, a basic math problem of 76 times 9. You are used to, in the past, of taking 76, putting 9 underneath it, multiplying it out. 6 times 9 is 54, put down the 4, carry the 5. 7 times 9 is 63, add 5, 68. Your answer is 684. Great, wonderful, super way of doing that. But what we want to do is try moving you away from having to do that math the long way and making a problem using the distributive property that really is turning into 2 easier problems. So what we have here, again, is 9 times 76. An easier problem that I think would be to take 9 and multiply it by 70, and then take 9 and multiply that by 6. Here we've got 9 times 70 plus 6. So what we're going to do is we're going to multiply the 9 by the 70, and we're going to add it to the 9 being multiplied by the 6. 9 times 7, 63, and add my 0. So I've got 630. 9 plus 6, 54. So I'm going to add 630 and 54 together, and that is where I get my answer of 684. So as you can see, I took my single-digit number, the 9, and multiplied it by 76, but instead of keeping 76 together, I broke it into a 70 plus 6 because together those are the 9 times 70, the 9 times 6 are 2 easier multiplication problems. If you look down at number 5, we can do the same thing. Instead of multiplying 5 by 88 the long way, let's think of this as 5 times 80 plus 5 times 8. So we are simply, because we have the 5 in front of the parentheses and no operational sign, we're going to multiply 5 times the 80, and we're going to multiply the 5 times the 8, or we're going to distribute the 5 through the parentheses. So 5 times 80, I'm thinking 5 times 8 is 40, and add this last 0, so for 400. And I'm thinking 5 times 8 is 40. 400 plus 40 is 440. When we get good enough, and some of you I think are already there, we can just do that in our head really quickly. Number 6, same concept. Instead of multiplying 8 times 27, we're going to multiply 8 by an easier number such as 20, and then multiply 8 by another easier number such as 7. Distribute the 8 to the 20, distribute the 8 to the 7. 8 times 20 is 160, because we know that 8 times 2 is 16 when we add that last 0. 8 times 7 is 56. And then in my head, I'm thinking 160 plus 40 gets me to 200. I still have to add another 16 to make my 56. I've got 216 as my final answer. So again, distributing to get to mental math would be simply taking your multiplication problem and breaking it into easier multiplication problems and distributing through whatever you have outside the parentheses. I will take us pause right here, and you will add a cheat sheet to number 2 for distributing to mental math. Number 3, combining like terms. This one gets a little bit trickier, but if you just follow along step by step, I think it's very handleable, if that's a word. W plus 2W plus 6 plus 1. When you look back at your vocabulary, we talked about like terms as being terms that have the same variable raised to the same amount. So terms that have the same variable raised to the same amount. So if you look at number 7, we've got a W, we've got a 2W, we've got a 6, and we've got a 1. The first thing we want to do is we want to identify the terms that are alike, or that are like terms. I have a W here, and I also have a positive 2W here, which I know, since they are a variable raised to the same power, they both are W and W with no exponent, or you could also say W to the power of 1, 2W to the power of 1. We can combine them. We've got W, which is also a 1W, and 2W to give us 3 W's. And then, as you know, positive 6 and positive 1, been doing this your whole life, can be added together to give you a 7. So, combining like terms in this instance would be W plus 2W and 6 plus 1. And together we have simplified that long 4-term expression into a 2-term expression that would mean the exact same thing, 3W plus 7. Notice what I did. For my like terms of W and 2W, I circled them. I used a symbol, such as a circle, to help me remember that those two go together. And then I used rectangles for my constants, or my 6 and my 1. I would like you to do this process. I like to call it coding. It's our own way of using coding, I guess, to help you keep straight what terms go together or what terms can be combined. So number 8, same thing. I want to code this. I'm going to start with my first term always. I'm going to put a blue circle around it. My next term is positive 2s. I know that 9r and 2s can't be combined because they're not even the same variables. I look at my next term and it's negative 3r. I know that a 9r and a negative 3r can be combined because it is a variable raised to the same power. So I'm going to circle that with a blue as well, so I know that my blue circles can be combined together. 6s does not combine with 9r, so I'm going to go to my next term. My next term is a positive 2s. I'm going to put a green rectangle around it, and I'm going to look at my positive 6s and think, can I combine them together? The answer is yes. I'm going to put a green rectangle around that as well. Combine my symbols that are the same. 9r minus 3r is 6r. 2s plus 6s is 8s. 6r plus 8s is the simplified version of that 4-term equation. 9r plus 2s minus 3r plus 6s means the exact same thing as that. I'm going to do this one a little bit more quickly here to save us some time on the video. I know that the x and my positive 3x are not the exact same, but they are like terms. They can be combined. I know that my positive 6, I'm going to put a triangle around those, this one, and my negative 2 are constants, so they can also be combined. Finish up, x plus 3x, so this x plus this 3x gives me 4x. The plus 6 and the minus 2 gives me plus 4. 4x plus 4 is my simplified version of those like terms. Take a break here, add your cheat sheet idea, and then we're going to move down to the last main idea. The last main idea is number 4, distribute to simplify, very much like our second main idea, in which we were taking multiplication problems and making them into easier multiplication problems. In this case, we are set up to distribute, and we are simply going to take whatever we have outside of the parentheses, and we're going to multiply it through everything that's inside the parentheses. So in this case, we have 7 times a plus 2. 7 times a is 7a. When distributing, you are always using multiplication, because this 7 being outside of the parentheses and no operational sign between them automatically indicates multiplication. 7 times 2 is 14, so 7a plus 14 is how I would distribute my 7 through those parentheses. Again, I want to give my 7 evenly to the a, evenly to the 2. Number 11 gets a little bit longer, but nothing all that complicated. If you just think, I want to multiply 7 by 2, I want to multiply 7 times 6, and I want to multiply 7 times negative 4d. Don't forget this negative sign here. So 7 times 2 is 14. Change color here. So 7 times 2 is 14. 7 times a positive 6 is 42. And 7 times a negative 4d is 7 times negative 4 is negative 28. And we keep our d attached. So my distributive form of problem number 11 is 14 plus 42 minus 28d. One thing that you should be noticing is that we have a 14 and we have a positive 42, which are like terms. We can continue to simplify this as 56 minus 28d because of the fact we have like terms that can be joined together. Number 12, last one I have for you. N stands all by itself, but we do have some distributing to go on here with the 3 throughout the n minus 1 in parentheses. So I'm going to leave my n as n, and I'm going to add my plus. I'm going to add my 3 being distributed to the n, which is 3n. My 3 is being distributed to the negative 1, which is negative 3. And then my plus 4 just tags right along with it because there's nothing to distribute. It is separate from what's inside the parentheses. When looking at this problem, you can see that we have some like terms. We have a positive n. We have a positive 3n. We have a negative 3, which is a constant. We have a positive 4, which is a constant. Combine your circles. N plus 3n is 4n. Combine your constants. Negative 3 plus 4. Use your number line. Start at negative 3 and add 4. We end up with a positive 1. Crazy as it might sound, this entire, grab the right color here, this entire equation, n plus 3 times n minus 1 plus 4, really is the same as 4n plus 1. Exact same thing as 4n plus 1. That is the end of our notes. We'll continue talking about this as we go throughout the school year. Make sure you add your cheat sheet, and good luck with your assignment.